Okay, good afternoon. We are getting down to the shop floor planning and job sequencing. And in this class, we'll be able to cover what we call Johnson's rule and the Gantt chart. Okay, so Johnson's rule and the Gantt chart. Now, what does Johnson's rule state? Okay, so Johnson's rule states that if the shortest processing time for the job is in machine 1 or work center 1. We do that job based in the schedule. Okay. But if it is machine 2, but if it is in machine 2, okay, if it is in machine 2 or work center 2, we do that job last in the schedule. So this is what Johnson's rule state. All right, so now there's the aspect of, okay, following the sequence. So now we look at the overall, the smallest time, so a process time for this operation says the company receives parts from the suppliers to be used in the manufacturing departments. The quality control departments must perform operation when shipments are received. Operation A, you draw a random sample, package and deliver to testing. And Operation B, test the materials and issue a disposition report. There are currently 6 shipments waiting to be processed. The time estimates for processing these shipments through quality control are, so you have the shipments, 6 of them, Operation A in hours, and Operation B in hours. Okay. So the processing time for all what we are doing now is 0.7. This is the shortest processing time for all the jobs. Okay, so we are going to, if it is the shortest processing time, if it is in machine A or operation A, we will do that job first in the schedule. But if it is in operation B or machine B, we do that job last in the schedule. So this is about what this one goes for. All right, so we have this one here where we are now simply saying, okay, simply saying that for these 6 jobs, the shortest processing time is 0.7. So since it is 0.7 is in operation A, we are going to do job 4 or shipment 4 first. So shipment 4 will be done first, okay, because it's in operation 1 or A. So we know that this one will be worked on first. All right. So this is the 4 that we have. Then we move, we look at the other shortest processing time for the remaining times. The other shortest processing time for the remaining times is the 1.0. Now 1.0 is meaning you're going to do job 1 last. Job 1 will be done last. Okay, so this one will be done at last. Because it is the one is in operation number B. We build up for the remaining times. So for the remaining times, the shortest time is 1.1. So 2 is an operation A, will be done first. So it will be done where there's a 4, be done first. Okay. Then we are going to go for the remaining times for these ones. It is 1.2, which is an operation A. So 3 will be done after 2. So here. Okay, so this one will be done like that. This job, you can take it as a job that way. The smallest time for the remaining times is 1.5. 1.5 is here. So 5 is done in operation B. So 5 goes that way. And then we have the last one, which is the job 6, will be done here. So this is a job sequence using Johnson's rule. Okay. So we have this one as job sequence using Johnson's rule. So use Johnson's rule to set the sequence of processing the shipment through quality control. So it's 4 to 2 to 3 to 6 to 5 to 1. So this is the job sequence that we have right now. So the Gantt chart is drawn based on the job sequence. So Gantt chart is drawn based on, okay, based on the job sequence obtained from Johnson's rule. Okay, so based on the job sequence obtained by Johnson's rule. So this is what happens here. Okay. So this is what goes on. So now as we come here, as we draw the Gantt chart, we have, okay, so we have, okay, so we have since we have the sequence, so the Gantt chart to be drawn based on a sequence that we have obtained. Okay, so without the sequence, the Gantt chart can't be drawn. Okay. So okay, so now this is how we are going to do a Gantt chart. So for the Gantt chart will be drawn on this one. Okay, so we'll do a Gantt chart here. Okay. So now this Gantt chart, we have the two operation A and B. So under this one, we know that the starting job that we are working on right now is job 4. Okay, so job 4 is a starting job and it's taking how many? Job 4 is taking in operation A is taking 0.7 hours. So job 4 is taking 0.7 hours. So by the time we are working on this job and taking 0.7 hours, what was going here is that since it's the same job or the same shipment that should be worked on as we look at operation B, so at this time, there is an idle time because the people in department A, they're waiting for it to be fully completed here in A. That's when they can start working on it in operation B. So there is idle time. Now that it has finished in operation A, they can start working on it in operation B. So in operation B, the shipment 4 is taking 1.6 hours. The 1.6. Okay, so 1.6 hours. By the time they're finishing working on this job 4 in operation B, there was something that was going on in operation A. In operation A, they would have started working on job 2, all right? So job 2 is taking 1.1. So it will be slightly take a little bit time area than the whatever it is that we have done here. Okay. So please take note of that. All right. So let me just start it up for the Gantt chart. Okay. So on this Gantt chart, it is one of the important component as we look at the shop floor planning and job sequencing. So we'll take time to explain. So the sequence was obtained using the Johnson's rule. The shortest processing time was 0.7. It was on operation A. So 4 starting, because it was in A, we do it first. And of course, now we look at the smallest here for the remaining was 1. Then 1 would have been done last because of the fact that it was in operation B. The remainder here was for the smallest was 1.1, which is 2, should be done here. Then also getting down to the other one, the remainder here is smaller, is 1.2. So 3 would have been done here because it is an operation A. Then the remainder for this remaining, the shortest time is 5. So this 5 would have been done last because it was in operation B. And then of course here we have 1.9 of 6. So this is the optimal sequencing. Okay, so optimal sequencing is actually given by 4 to 2 to 3 to 6 to 5 to 1. So now under this one, we have operation A and operation B. So when the first shipment 4 is being worked on, it was taking 0.7 hours. Whilst here people were idle because it's the same job that they actually waited for it to be finished, to finish running in operation A so that they can start running it in operation B. Now 4 is being run in operation B. It's taking 1.6. So by the time they're finishing working on shipment 4 in operation B, here they would have started working on job 2, which was taking 1.1. So here it was taking 0.5 hours longer. And then these people in operation A should not wait. They can quickly switch to job 3. So job 3 is taking 1.2. So job 3 is taking 1.2. So meaning this one is taking 0.7 hours longer than what is happening in B. So now job 4 has been fully completed. Job 2 should be fully completed, and for it to be fully completed, it should also run in operation B. So 2 in B is 2.7. By the time they're finishing running job 3, okay, here it is taking 2 hours longer. Okay, so by the time they're finishing running job 2 in operation B, they would have started working on job 3. Okay, they started working on job 3 in operation A. So job 3 in operation A, okay, job 3 in operation A, okay. So here we're simply saying, by the time they're finishing running job 3 in operation A, okay, it's taking 0.7 hours longer than this one. So job 2 should run in operation B. Job 2 in operation B is 2.7. Job 2 is 2.7. So which is taking 2 hours longer here. So by the time they're finishing working on job 2 in operation B, they would have started working on job 3 in operation A. Job 3 in operation A, job 3 in operation A is 1.2. So 1.2 hours. So they have no time to waste here or to wait for anything. You can quickly switch on to job 6. So job 6 in operation job 6 in operation A is taking 1.9. Okay. So it's taking 1.9 hours. So meaning that here already we know from a 2, the 1.2 has gone. So 2 minus 1.2 is 0.9. Okay. So 2 minus 1.2, so 2 minus 1.2 is 0.8. Okay. So 0.8 under here, this one is 0.8. Okay, so meaning that by the time they're finishing running job 2, job 3 in operation A would have finished already, and there's still time that the people in operation A can still go to another job, which is job 5. So job 5 is taking job 5 is taking, that is job 6, that is job 6 in A is taking 1.9. Okay, 1.9. So 1.9 is what it's taking. So meaning this job 6 is taking 1.9. So meaning it's actually taking 1.1 hours longer. 1.1 hours longer here. Okay. So meaning by the time they're finishing running job 6 in operation A, the people in department B, they should run on job 3. So job 3 in B is taking 1.4. So it's taking 1.4 here, job 3 in B, 1.4. So meaning this one is taking how many hours longer? So this one is taking 0.3 hours. So 1.4 minus 1.1, 0.3. So it's taking 0.3 hours longer. Okay, so it's taking 0.3 hours longer. So by the time they're finishing running job 3 in B, the people in operation A would have started running job 5. Job 5 is taking 1.6. Okay. Here, job 5 is taking 1.6, meaning it is taking 1.6 there. It's actually taking 1.3 hours longer. 1.3 hours longer. So by the time they're finishing running job 5 in operation A, the people in department B would have started running job 6. Job 6 taking 2.9. Okay. So 6 is taking 2.9. So we can simply say 2.9 minus 1.3. So you're taking 1.6 hours longer. 1.6 hours longer. So by the time they're finishing running, job 6 in operation B, the people in department A would have started running job 1. Job 1 is taking 1.5. So meaning job 1 is taking 1.5. Okay. 1.5. So meaning these ones are still taking 0.1 hours longer. 0.1. So meaning that 0.1, meaning that now we only have job 1 to run in. We have 2 jobs now running, which should run in department B. So the other 5 should run in department B. So 5 in B is 1.5. 5 in B is 1.5. Then 1 also should run in B, which is 1.0. So 1 in B is 1.0. So meaning this entire is idle time for operation A. Okay. So the idle time for operation A will be, so idle time operation A is going to give us what? 0.1 plus 1.5 plus 1.0. So 0.1 plus 1.5 plus 1, 2.6 hours. And then idle time for B. Okay, so this is for A. Idle time for B. Idle time B is equal to only 0.7 hours. So this is what we have. So now what is going on here is that the total time required here, how much total time is required to process all the 6 shipments through quality control. We start adding now here to be 0.7 plus 1.1 plus 1.2 plus 1.2. Okay. So it's 0.1 plus 1.2. Okay. Then plus the 1.9 plus 1.6 plus 1.5, then plus the idle time in this case, which will give us, we can say 0.7 plus 1.1 plus 1.2 plus 1.9 plus 1.6 plus 1.5. Okay. And plus, okay, plus the idle time that we have on this one, which will give us a total of 11.8 hours. Okay. So the total time required is 11.8 hours. Okay, so just on the recap on this one, the job sequence on this end was 4 2 to 3 to 6 to 5 to 1. So this was the job sequence. So the fact here is that the job should be fully completed when it has been run in department A and when it has also been run in department B. So department A and department B, that's when the job is fully complete. So on this one, when you're running job 4, and the department A is taking 0.7 hours, meaning that here people have idle time. So this job now should run in department B for it to be fully complete. Okay, so 4 here is taking 1.6 as from the information given in the question. So 4 is 1.6. So by the time they're finishing running job 4, in the operation A department would have started running job 2. So job 2 in operation A is taking only 1.1 hours. Okay, so this 1.1, they can finish quickly. And then while the people in operation B are still working on job 4. So since they have finished working already on operation A quickly on job 2, then they can switch on to job 3 in operation A. Job 3 in operation A is taking 1.2. Now, between the completion time of job 4 and job 2, okay, the people in operation B were taking the number of hours longer. They were taking 0.5 hours longer here. 0.5 hours longer in operation B between the completion time of job 2 and job 6. Now, operation A, they can switch to job 3, where they are taking 1.2 hours. So 1.2 hours here, they're taking 1.2. So meaning they are actually taking 0.7 hours longer. Okay. So now, what is happening in operation B is that by the time they finish running job 3 in operation A, people in operation B would have started working on job 2. And job 2 is taking 2.7. Okay, so job 2 is taking 2.7, meaning that it is taking 2 hours longer, okay, than job 3 in A. By the time they're finishing running job 2, people in operation A would have started working on job 6. Job 6 taking 1.9. Job 6 is taking 1.9. Okay, so meaning that this one will be taking the 0.1 hours longer. Okay, 0.1 hours longer. So it's a 0.1 here, 0.1 hours on this end. Okay, so that 0.1 is between the completion time of these two jobs. So 0.1. So meaning that by the time they're finishing running job 2, people in operation A would have finished running job 6. So they can switch to job 5. Job 5 in operation A is taking 1.6. So job 5 is taking 1.6, meaning that it's taking 1.5 hours longer. 1.5 hours longer. So by the time they're finishing running job 5 in A, people in operation B would have started running job 6. Job 6 is taking 2.9. All right, so 2.9 is in operation B. Okay, here the job 4 is fully complete, job 2 is fully complete. So job 3 is not yet fully complete. So job 3 in operation B is taking 1.4. So meaning that here we are going to have a 1.4. That is job 3 is 1.4. So meaning that here they still have 0.1 hours longer. So what is going on here is that they can now start by the time they're finishing running job 5. Job 3 is fully complete, is fully completed. So they can start running job 6 here in operation B. Job 6 in operation B is taking 2.9. Okay, so job 6 is taking 2.9 here. So 6 is taking 2.9. Okay, so 6 is taking 2.9, meaning that this one is taking 2.8 hours longer. Okay, so meaning now that by the time they're finishing running job 6 in operation B, people in operation A would have now started working on job 1, and job 1 is taking 1.0. Job 1 is taking 1.0 here. Okay, so job 1 is taking 1.0. So meaning that this 1.0, okay, this other side is so job 1 taking 1.0, and all the jobs are fully done. So meaning that 2.8. So this one, job 1 is taking 1.5 hours in operation A. So 1.5 hours in operation A, meaning that by the time they're finishing completing job 6, here we have the excess time of 2.8 minus 1.5. 2.8 minus 1.5 is 1.3. So job 6 completion time is taking 1.3 hours longer. 1.3. All right, so meaning now that the jobs in operation A they are fully completed. So people in operation A have finished working on all these jobs. And now the duty, so up to here, okay, there's idle time of 1.3. So they can now finish running job 5 in operation B. Running job 5 in operation B is taking 1.5 hours. Then after that, now they can work on job 1 so that job 1 can be fully completed. Job 1 is taking 1.0. So all this is idle time. All this is our idle time for operation A. So the total idle time for operation A, idle time A is actually equal to the, okay, so this one is equal to 1.3 plus 1.5 plus 1.0. So 1.3 plus 1.5 plus 1 is 3.8 hours. Idle time for B is only 0.7 hours. So what is going on here is that we now need to sort out the total time required. So total time required is given by, we add the total time will be 0.7 plus 1.1 plus 1.2, then plus 1.9, then plus 1.6, plus 1.5, all right, then plus 1.3, including the total time for idle, 1.3 plus 1.5, then plus 1.0. The total time will be 0.7 plus 1.1 plus 1.2 plus 1.9 plus 1.6 plus 1.5 plus 1.3 plus 1.5 plus 1.0. It's giving us 11.8 hours. So this is the final answer for this problem. That is using operation A. Even if we use operation B, the total time should be the same. So we can say for B, 0.7 plus 1.6, then plus 2.7 plus 1.4, then plus 2.9, yeah, 2.9 plus 1.5, then plus 1.0. Okay, so 0.7 plus 1.6 plus 2.7 plus 1.4 plus 2.9 plus 1.5 plus 1. So it's also giving us 11.8. So this is what happens for the Gantt chart. All right, so we end the class for now.